We're going to be looking at exponent rules or exponent properties. Some people like to memorize these. I get sometimes confused, so I always like to have something to fall back upon, and that would be expansion. When I look at x cubed times x squared, I know from the meaning of exponent there are 3 x's being multiplied times another 2. So if I want to again condense this, I'm going to get x to the 5th. Looking at the next scenario, 3, and then there's going to be 6 y's. And I'm going to multiply that by a 4 and another y. Well, I know I can only multiply 2 things together at a single time. So what I'm going to do is kind of sort this. I always like my numbers together and then all my variables that are the same. So I sorted using what we call the commutative property, which allows me to move things. Multiplying these numbers now, 3 times 4 is 12. And looking at my exponents and counting them up, I get y to the 7th. So if I'm looking at exponents, it looks like I got 6 and 1 is 7. I got 3 and 2 more. I'm going to keep the base, and I'm going to end up adding those exponents. In the next case, again, I don't like to memorize, so I'm going to use expansion. What this means is I have 5 of these parentheses, and each parenthesis contains x cubed. So I will write 5x cubes. And if I really wanted to, I could write all these out 3 times and then add up how many I have, and it looks like I have x to the 15th. Let's try the next one. I'm going to have y to the 6th twice. If I'm not sure, I kind of try to visualize it at this point, so I'm not writing all these y's down, but we will. And taking a look then, I have y to the 12th. So what's happening here, it looks like 3 times 5 is 15, 2 times 6 is 12. So it looks like I keep my base and I multiply the exponent. So we almost had to use the first property in order to come up with the second. And now we'll be using the second to come up with a third. And looking at the first problem, it says I want 5 of these parentheses. So we'll write 5 of them down. And then what I'm going to do is do that sort thing. I want all my x's together, and it looks like there were 5 of those. And then I want all my y's together, and there were 5 of those. Using either the first property or thinking all this expansion, looking, I have all these x squareds 5 times. I have 5 times that x squared. I have 10 x's. 5 times I have that y. I have y to the 5th. So I really want to write that as down here. It would be x to the 10th, y to the 5th would be the answer to this problem. So maybe you can see what's going on with that 5. Again, we'll try the next one using expansion. I have 3y to the 6th, and I'm going to write that 2 times. And now simplifying by getting my 3's together and my y to the 6th together. 3 times 3 is 9. Y to the 6th twice gives me y to the 12th. So looking on what happens to that power of 2, the power of 2 goes on the 3 and applies to the 3. Now notice it's not 6, it's 3 squared, and it also applies to the y. So it's a little bit like property 2, in fact, that I take the n on the a and the exponent n on the b. And then I have to remember that I'm multiplying those powers. If you forget, just use expansion. And that's how we're going to come up with property number 4. What do I do when I have division? Well, through expansion, I'm going to go ahead and write down my 5x's and my 3x's in my denominator. If I recall, on a fraction, if I have the same value in the numerator as I do in the denominator, they cancel out and make a 1. These two will cancel out and make a 1. These two will cancel out and make a 1. So I have x to the 2nd. Trying in the next scenario, I have 2x's and 7. So now in this case, my denominator has the larger power, the exponent. But again, they'll cancel and make a 1. They'll cancel and make a 1. And I end up with 1 over x to the 5th. So I ask myself, when I have 7 x's in the denominator, 2 in the numerator, they all cancel, leaving me 5 in the denominator. And if you look at this and try to come up with some rule that you want to use, if you can remember the rule, looks like I'm taking my base A and I'm taking my exponents and I am subtracting them. Notice 5 minus 3 is 2. So that didn't seem to give me a problem. Take your numerator and subtract the denominator. So when I do in this case, if I take 2 minus 7, I get negative 5. Well, negative 5, these two things have to be equal to the same. So it looks like a negative exponent is telling me placement. The negative exponent's in the numerator, it's telling me it belongs in the denominator. So that's what a negative exponent's going to do, is tell me placement. We'll be looking at that further. In the next scenario, division is no different than multiplication. In this case, if I just want to take these fractions, which are division, and look at each one, looks like a x squared and y. That's 3 here and 3 in the second one, which would be y to the 6th. Taking a look at what's going on here, the x goes to the squared goes on the x in the numerator, and the squared goes on the y in the denominator. So it goes to both numerator and denominator. And it works like that because it is multiplication, and exponents are multiplication, and they work well with division. Looking in the second scenario, again, I can write this 2 times, grouping my numbers, grouping my common x's, grouping my y's. And if I take a look, 2 squared y to the 6th, and I get y to the 8th. So it's kind of like you distribute that, and you can because you're using the same operators. Multiplication and division work together well. In fact, they just undo each other. Here's kind of a weird scenario. Anything to the 0 power is 1. If I gave you 5 to the 0 power, that is 1. Whatever to the 0 power is 1. And we can show why this is true. I'll give a specific example, so it's not a proof, because I'm using values here, and I have a squared over a squared. According to my rule above for division, 2 minus 2 is equal to 0. But if I look at expansion, 1 and 1 is 1. So therefore, a to the 0 is 1. Anything to the 0 is 1. And the last property that we need to spend a few minutes on here is this negative power. And that's going to tell me placement. Just like a negative number tells you left or right of 0, a negative exponent either tells you to be in the numerator or the denominator. So if it's negative, it's telling you placement. This negative 3 tells me those x's should be cubed, but they should land in the denominator. Y to the negative 2 tells me they should be y squared, but they should really be in the numerator. Notice it doesn't matter if it's in the denominator, it just says go to the numerator, and if it's in the numerator, go to the denominator. So negative exponents tell you placement on the division bar. Negative numbers tell you placement with respect to 0. When I say negative numbers, I'm saying negative 2. It is not an exponent. It's saying you are on this side of 0. When I say I have negative 2 in an exponent position, it's telling you it needs to land in the denominator, or if it's in the denominator, it needs to move to the numerator.